Hello students, welcome to experiencetutor.com. Today we'll start with one more lesson, class 12, physics, electrostatic part 2. Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you. Question number 15. Explain quantization of electric charge. The magnitude of all charges found in nature are in integral multiple of a fundamental charge of electron or proton represented by E. This fact is known as quantization of electric charge. Thus, charge Q on a body is always represented by Q is equal to NE, where N is any integer and E is the charge of an electron. E is equal to 1.6 into 10 to the power minus 19 Coulomb. The quantization of charge was first suggested by English scientist Faraday. It was experimentally demonstrated by Milken in 1912. Question number 16. What are quarks? What is up quark U and down quark D? Proton and neutron consist of another fundamental particles called quarks. A proton and neutron consist of 3 quarks each. These quarks are of two types. The quark possessing plus 2 by 3 E charge is called an up quark U and another having minus 1 by 3 E charge is called a down quark D. The composition of proton is indicated as UUD and composition of neutron is indicated as UDD. Thus, matter is formed of such quarks and electrons. The independent existence of quark is not detected so far. Question number 17. Explain conservation of electric charge with an example.
The algebraic sum of electric charges in an electrically isolated system always remains constant, irrespective of any process taking place. In an electrically isolated system, a charge can neither enter from outside nor escape from inside. Any charge-less thing can enter or leave such a system. In an experiment of glass rod and silk cloth, before rubbing glass rod with silk cloth, the net charge of them is zero. After rubbing the glass rod with silk cloth, the glass rod becomes positively charged and same amount of negative charge is received by the silk cloth. Thus, after process of friction, the net charge of the system glass rod plus silk is zero. Question number 18. Describe about the unit of charge. In SI system, the unit of charge is Coulomb. It is denoted by capital C. 1 coulomb of charge is that charge which, when placed at rest in vacuum at a distance of 1 meter from an equal and similar stationary charge, repels it and is repelled by it with a force of 9 into 10 to the power 9 Newton. In CGS system, the unit of charge is stat coulomb, or ESU of charge. Question number 19. Explain conservation of electric charge with the help of an experiment. Let us consider the initial charge in a box having thin walls is zero. A highly energetic photon enters in the box. A photon is a chargeless particle. As the photon enters through a box, it produces an electron-positron pair. After the pair production in the isolated system, the net charge is zero because the charge electron and positron are equal and opposite type. The initial charge of the system was zero, therefore the charge is conserved. Question number 20. Explain Coulomb's law. Derive an equation for Coulomb's law in vector form. French scientist Charles Coulomb deduced a law for electrical attraction and repulsion between two charges. The law states that the electrical force between two stationary point charges is directly proportional to the product of their charge and inversely proportional to the square of the distance between them. The force acts always along the line joining the two charges. Therefore, according to Coulomb's law, the electric force between 2-point charges Q1 and Q2 separated by a distance r can be given as F is directly proportional to Q1 into Q2. F is inversely proportional to r square. The distance between them is r. Therefore, F is proportional to Q1 Q2 upon R square. F is equal to K Q1 Q2 by R square. Where K is a positive constant of proportionality called Coulomb constant. K is equal to 1 by 4 pi epsilon, where epsilon is absolute permittivity of the medium. If the medium is air or free space, K is equal to 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Therefore, F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square, where Q1 Q2 are stationary point charges and R is the separation between them in air or vacuum. Also, 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square upon Coulomb square, where E0 is equal to permittivity of free space, which is equal to 8.85419 into 10 to the power minus 12 Coulomb square per Newton meter square. Coulomb's law in vector form. Let the position vector of charges Q1 and Q2 be R1 and R2 respectively. We denote force on Q1 due to Q2 by F12 and force on Q2 due to Q1 by F21. The vector leading from 1 to 2 is denoted by R12 or R21. R21 is equal to R2 minus R1. R12 is equal to R1 minus R2 is equal to minus R21. The magnitude of vector R21 and R12 is denoted by R21 and R12 respectively. R12 is equal to R21. The direction of vector is specified by a unit vector along the vector. To denote the direction from 1 to 2 and from 2 to 1, we define the unit vector as R21. Unit vector R21 is equal to R21 upon R21. Unit vector R12 is equal to vector R12 upon magnitude of R12, that is R21 is equal to R12. Therefore, Coulomb's force law between 2-point charges Q1 and Q2 located at R1 and R2 in is then expressed as F21 is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R21 square, unit vector R21, to give the direction. Remarks on Coulomb's law. The above equation is valid for any sign of Q1 and Q2, whether positive or negative. If Q1 and Q2 are of the same sign, F21 is along R21, which denotes repulsion as it should be for like changes. If Q1 and Q2 are of opposite sign, Q2 F21 is along minus R21 or R plus R12, which denotes attraction as expected for unlike charges. Thus, we do not have to write the separate equation for the cases of like and unlike charges. The force F12 on charge Q1 due to charge Q2 is obtained by supplying interchanging 1 and 2. Simply interchanging by 1 and 2. F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square unit vector 1 2 is equal to minus F21. Thus, Coulomb's law agrees with Newton's third law of motion. Define electric constant. Dielectric constant of a medium is the ratio of the absolute electric permittivity of the medium to the absolute electrical permittivity of free space. Dielectric constant has no unit. K is equal to epsilon r, which is equal to epsilon upon epsilon naught.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.